Do you want to excel in maths and science? If your answer is yes, then let me tell you, go ahead with Infinity Learn courses. And to get best discounts, subscribe right now. The link is given below in the description box. Hello my dear students, welcome to my channel. So as you all know that I'm Divya, your science expert, and today in this session I'm going to take very interesting topic, and the topic is taken from chemistry. But before I move ahead, I would really like to share with my students, like if you purchase the course, then I have one offer for you. You can just use this coupon code DE10 and you will get 10% extra discount. So how excited it is. So hurry up, use this coupon code and avail 10% extra discount. Okay, so the topic today that we are going to talk about is taken from Is Matter Pure? It is very interesting chapter, let me tell you. And particularly, I will be teaching you the concept factors affecting rate of dissolving. So what we are waiting for? Let's get started and let's learn about it. Okay, so activity time is always a fun time. Tell me, you can see a picture on the screen. I want you to identify that what is actually happening here. You can see the picture, you can pause the video right here, observe it, guess it, and whatever you guess, just write in your notebook. And then unpause and match your answer with my answer. So I hope you got the right answer. So let me tell you that in this picture you can see that we have a glass of water and then we are adding some salt into it. We are stirring with the help of spoon and ultimately what we get? We get salt solution. What we get? Salt solution. Okay, so let's start with very basic. Then we'll, directly jump to the solution part. So what is matter? Anything that we see around ourselves which occupies space and has mass, that is called as matter. Anything, for example, I have this pen. When I'll keep it, it will occupy certain space and also it has certain mass. Maybe less mass or more mass doesn't make a difference. But if anything is occupying space, maybe bigger space or smaller space, and anything which has mass, lighter or heavier, it is called as matter. So whether you talk about gas cylinder which contain gas, whether you talk about water, whether you talk about books, pen, chair, table, everything comes under the category that is matter. Because when we keep them, they occupy space also and they have certain mass also. And matter exists in all three states: solid state also, liquid state also, gaseous state also. Even the air occupies space. So air is also a matter. So matter can be divided into two categories: pure substances and impure substances. And impure substances, they are called as mixtures also. So pure substances are those, which have definite properties, which have definite composition. Like if I talk about water, if water is pure, then obviously it will have fixed melting and boiling point. So all the pure substances, they have got fixed properties. Okay, so elements and compounds, all the elements and compounds, they are pure substances. And elements, like the smaller particle which form the element, they are atoms, and the smaller particle of the compound is element, and element is ultimately formed of atoms only. And if we talk about mixtures, in this, when you mix two or more things together, mixture is formed when two or more substances are simply mixed, but they are not chemically combined. Means there's no bond formation, they are just mixed up. So that is a mixture. I hope you all relish eating, the khatta mita mixture that you get in market of Haldiram. So it is a mixture because it contains nuts also, it contains peanuts also, it contains some bhujia sort of thing also in it. So everything is just mixed up, but they are not chemically combined. So that is a mixture, right? So if we talk about solution is a type of mixture which we can call it as impure substance also. Right? But solutions are homogeneous. Now, what do we mean by this term homogeneous? See, if anything is uniform in composition and properties, then you call it as homogeneous. still it is a mixture. But if it is uniformly present, like for example, if you have salt solution, can you make out salt and water in the salt solution? No. We don't get to see separate boundaries of salt or water. They get thoroughly mixed up, right? But still it is a mixture. So that kind of mixtures where the components, they thoroughly mixed and they have definite properties also, then they are called as solutions. They are homogeneous, and solutions are always homogeneous. But not all, because we come across certain, solutions which are not homogeneous. For example, if you mix oil and water, they don't, mix into each other. Right? Okay. So solution can be defined as a homogeneous mixture. That means uniform composition and properties throughout. Right? So solution, for example, if you add lemonade mix into water, you get a lemonade. If you add sugar to iced tea, you get sweet tea. If you add chocolate sauce to milk, it becomes your chocolate milk, which everybody like to drink. If you add jello powder into boiling water, you get jello. So all these examples, they come under solutions. So we have different sort of solutions depending upon how many components we are mixing. Because we can mix 2 components, we can mix 3 components, we can mix 4 substances together, we can mix many substances together to form mixture. But the commonly formed solutions are binary solution. Binary solutions are those which are formed by mixing 2 components, right? One component is called as solute and other component is called as solvent. One component is solute and other is solvent. Now, what is the difference between two? See, when you take water and you add salt to it, right? So, salt is always taken in a small amount. It is solute. So, all the component which is taken in small amount, is called as a solute. And the component which in regards to solute is taken more, that is called as solvent. So it is taken in more amount. Okay. Also, one thing you must have noticed, that salt gets dissolved. It gets dissolved. So solute always gets dissolved. Right. And solvent, it dissolves solute into it. So solvent is the one which dissolves solute. Right. And solute is the one which gets dissolved. So for example, you have solvent present in more amount, solute present in less amount comparatively. So when you add it into this, solvent will dissolve solute and solute will get dissolved and ultimately we get solution. Okay, so we should know about solubility, that what exactly is solubility. Let me tell you. See, when you are adding solute to any solvent, right? So how much solute is actually dissolving in that solvent at given temperature? That means you're not increasing the temperature. At room temperature, if you add salt into water, you stir it. You add more salt into water, you stir it. You add more salt to water, you stir it. But the time will come when the water will stop dissolving salt, right? And salt will settle at bottom. So the amount of solute which can be dissolved at given temperature is called as solubility. But if you heat that particular thing, which like the solution which is not dissolving more salt in it, then it will dissolve more salt into it. But solubility refers to amount of solute which gets dissolved in given amount of solvent at given temperature. That means we are not changing the temperature. Okay, and see, on the basis of solubility, we have 3 kind of solutions: saturated, unsaturated and supersaturated. So the one which can dissolve solute only, up to a certain level, they are called as saturated. Okay. The one which can dissolve solute more than their ability, they are called as unsaturated. And supersaturated, if you heat the saturated one, it will dissolve more solute into it. So it becomes supersaturated. Okay. And let's talk about concentration. Whatever solute you are adding to any solution, that is called as concentration. Whether it gets dissolved or not doesn't make a difference. If you are adding, let's say if I am adding 2 grams of salt into 100 grams of water, so 2 gram is the concentration. We are not concerned whether it is getting dissolved or not. Okay, but the amount which gets dissolved at given temperature will determine the solubility. So there is difference between 2 terms. How much you are adding is the concentration. How much actually gets dissolved is the solubility. Okay. Now factors that affect the solubility. Let's talk about it. See, three factors are responsible which affect the rate of dissolving: temperature, pressure and nature of substance. Let's take it one by one. Okay, temperature. I'll give you one example. I told you, suppose I take water, I add a spoon of salt to it, right? I stir it, it gets dissolved. I add another spoon. I stir it, it gets dissolved. So I keep on adding, but a stage will come when that particular solution will not be able to, dissolve more solute into it, right? But if I change the temperature, that means if I heat it, then it will dissolve, right? So this actually, like by heating, when I'm heating, that means I'm increasing the temperature. And when I'm increasing the temperature, it is dissolving more. So that means the solubility is getting increased, or rate of dissolving is getting increased. So by changing the temperature, mostly the solubility increases. That is, more solute gets dissolved. But if you talk about, I'll tell you, if you talk about only gases, if I talk about only gases, so in case of gases, you know that gases are volatile. Gases, they are volatile, right? So when we increase the temperature, so obviously when you're increasing the temperature, gaseous particles, they will take that energy as their kinetic energy and they will start moving randomly. And when they start moving randomly, then what will happen? Their solubility will decrease because they will start coming out from the solution because of increased kinetic energy. So we say that in case of gases, increase in dash. What is it dash? Increase in temperature decreases the solubility of gas. Why? Because gases are volatile. They take that heat as kinetic energy. And when their kinetic energy increase, they start moving randomly and yes, they escape out from the solution. Okay, let's talk about another factor, which is pressure. So effect of pressure we have seen is more applicable when we are dissolving some gaseous substance. The reason being, what is pressure basically? Pressure means force applied per unit area. For example, here you can see that these are the gas particles and this is solvent. If you apply pressure, if you push them down with the help of piston or something, what will happen? More gaseous particles will be forced to go inside the solvent, right? But this is applicable only for the gaseous substance, more for the gaseous substance, because solids and liquids, they are not compressible, or liquid is compressible up to some extent, but solids are non-compressible. If you will increase the pressure, the solid, like the solid particles, solubility won't be affected in that case. Okay, got it? So increasing pressure can actually force the gaseous particles to get more soluble in the given solvent. That is the reason when you buy cold drinks from market, you know that it is sealed with a cap. So that means pressure is applied and it has been sealed. But when you open the cork, then what comes out? The gas comes out with great pressure because you are decreasing the pressure in that case. So increased pressure, it gets dissolved. And when you open that cork, it just, comes out because gases are always volatile, right? So increasing the pressure will increase the solubility. Third is nature of solute and solvent. Let me tell you, in chemistry, we have a simple rule that is like dissolves like. Like dissolves like. For example, oil and water, when you mix them, they are not miscible. They don't get dissolved. The reason being the nature of water and the oil is not same. Okay. But if you add salt to water, then it gets dissolved. I'll explain you with, just a simple example. If I talk about water, water consists of ions, right? If I talk of salt, salt also consists of ions. So they are somehow similar. That is with positive and negative ions, both of them. So they are like. So that is why like dissolves in like. But when you compare oil with water, then they are not similar in respect of ions, the type of ions. That is why they don't get dissolved. So like dissolves like. Another concept, let's take it, is ice cream a colloid? Let me tell you, you have to tell me actually, is an ice cream colloid? I know few of you must be thinking that what is colloid? Don't worry, I am here to simplify everything for you. Let me tell you that solutions can be of three types, depending upon the size of solute. Depending upon the size of solute particle. If the solute particle is very, very small in size, means the size is less than 1 nanometer, then it forms true solution, like salt in water. Okay? But if the size is very big, solute size is very big, let's say more than 100 nanometer, then if you mix it in a solvent, it will form suspension. For example, mud and water. Okay? And if the size falls between 1 nanometer to 100 nanometer, then the solution is called as colloidal. That, for example, like milk. Milk is a colloidal solution. Okay, now I think you got an idea about colloid. Tell me, is ice cream a colloid or not? See, colloids, I hope it is clear, they are those which have particle size intermediate between true and suspension. So let me tell you, when we talk about ice cream, it has got ice crystals, fat particles, and they are dispersed in water, sugar and air bubbles. So the range of particle lies between 20 to 50 μm. So that means ice cream is a colloid. Okay, so I hope it is clear to you. So with this, we have come to an end. I hope you have understood the concept properly. My one tip for my students, please make your habit to write and learn. Because whenever you learn something and write it down, you become more confident. Okay, and if you haven't subscribed my channel, just subscribe it right now, because it is the channel where you are going to get quality content. So thank you. Take care. Bye-bye.